Okay, so since we were not able to complete the review problems that I wanted to work through with you today during class, I'm going to post a couple of videos for you. In this one, I'm going to work through these problems using the table. And then what I'm going to do once the power comes back on and I'm able to access Wi-Fi, I'll go back and create a second video where I show you the equivalent steps using StatCrunch. All right, so again, this time we're going to walk through these and we're going to talk about how we would do this using the standard normal table. Now, as I talked about in the announcement, the testing announcement in my lab, typically the most difficult part of the Chapter 5 test is making sure that you know when to use each method. And the big things you want to look for there is, do you have a question that is asking you to find probability, or do you have a question that is asking you to find a data value? Okay, so notice in part A here, we're looking at a normal distribution, right, bell-shaped curve. These are always defined in terms of their mean and standard deviation. All right, so I'm going to go ahead and make a note for myself here. The mean is 100. The standard deviation of the bill amounts is 12. All right, and then I'm going to note that this question is asking me to find a probability. All right, now probability means I need to find the area under the curve. Now, when I'm looking for the probability or the area under a curve, the next thing I want to do is make a note for myself as to whether I'm looking at one value, an individual bill, or a sample of values. All right, and so we notice here we're looking at a bill, right? That's one individual value. So we're going to do this in terms of an individual value X. And then the last thing I'm going to do is look at the direction of my area. And since we're going more than 115, I know I'm looking for an area to the right. All right, now remember, there's some different ways these problems can be presented. So the equivalent probability notation here, this could be written, right? Find P, the probability that X, an individual bill, is more than $115. All right, that's the same process. Or I could be shown a graph, right? If I look at my normal distribution here, I'm using X, not Z, because the mean is not 0 and the standard deviation is not 1. All right, so if I were given this normal distribution and I were asked to look at the area shaded to the right of 115. All right, so again, I just want you to know all three of these questions are exactly the same that we're looking at here. All right, so if I'm going to use my table, then what I do with an individual data value is I convert it to a z-score by using my z-score formula. All right, now our z-score formula, you always start with your value, you subtract its mean, and you divide by its standard deviation. Now, if you need to round, you're going to round to 2 decimal places because that's how your table is set up. And I'm looking at a z-score here of 1.25. All right, now notice I'm not finished because this is not a probability that I found. It's a z-score. All right, the whole purpose of z is that you can take it to your table. So once I convert to z, right, then I can look it up 1.2 on the left-hand side, 5 in the second decimal place, and the area shown in the table is 0.8944. Now, this is an area. That means I'm getting closer to what it is I'm trying to find, but I got to remember that what's in my table is always an area to the left. So if I want to go to the right, all right, which I do here, this is greater than, then what I have to do is take the area in my table and subtract it from 1. And when I do that, I find that the area to the right, which is the same thing as the probability greater than, is 0.1056. All right, or there's about a 10.56% chance that a bill is more than $115. Okay, now, if you need to review this particular method, this is what we did in 5.2, right? Finding probabilities for individual data values. All right, now, the next thing that we need to look at here is how does this change when we're still asked to find a probability, right? Which means we're still looking for an area under the curve. But we're not looking at a bill, an individual bill. We're looking at a group of bills, right? Or a sample of bills. So the first thing I want to note here is I'm not looking at one value, right? I'm looking at a sample, and my sample size N is equal to 35. The other thing to note here is that because I'm not looking at an individual bill amount, right? I'm finding the probability for the mean bill, right? Now, a bill amount, that's X. But a mean, a sample mean bill amount is a value of X bar. All right? And then lastly, direction, right? This is going to be less than, so we know we're looking for an area to the left. All right, and notationally, this would be written, find the probability that a sample mean, X bar, right, because it's not just one bill, is less than $96. All right, now, this is going to be a very similar process because we're still looking for an area under the curve. The main thing that I have to remember is anytime I'm dealing with a sample mean, right, a value of X bar, I have to change my standard deviation. All right, for a sample mean, the standard deviation is not sigma, like we just used for an individual bill. It is sigma over the square root of N. So in this case, I'm going to take sigma 12, that's the initial standard deviation for individual bills, and I'm going to divide it by the square root of my sample size, right, which we saw was 35. Okay, so I'm going to go ahead and calculate this, right, get an approximation. Make sure that you don't round this too short. If you round it down to like 2 decimal places, it's going to cause rounding errors when you use it again. And that goes for this or for StatCrunch. So when you calculate your new standard deviation, keep it out to at least 4 decimal places. All right, that's the big thing to remember with the sample mean is you've got to recalculate that standard deviation. All right, now once I do that, then I'm going to follow the same process I just went through because I'm still trying to find an area under the curve. All right, that is convert it to Z and then go to the table and get my area. All right, so from here, I'm going to calculate Z based on this value of 96. Right, so our process for calculating Z, we always subtract the mean, and that does not change. All right, so I'm still subtracting that mean of 100. But because we're dealing with a sample mean, we're not using 12 for the standard deviation. We're using the standard deviation of X bar, which we just calculated at 2.0284. That's what you got to remember. With sample means, your standard deviation is different. All right, and using this new standard deviation, I get a value of Z. Again, I round Z to 2 decimal places of negative 1.97. Okay, and then again, the whole purpose of finding Z, you're not done because this is not a probability. It's not an area. All right, the whole purpose of finding Z is so that you can take it to your table. So negative 1.9 here. 7 in the second decimal place, and the area in the table, right, which again, the area in the table is always an area to the left, is 0.0244. And in this case, that's what we want, right, less than, so we don't need to subtract from 1, all right, we have found the area to the left, so we have found the probability that a mean bill amount, right, for a group of 35 is less than $96. Okay, so when a question asks you to find probability, What's important is to understand, are you looking at one value, like a bill, where you use sigma, or are you looking at a sample of values, right? A sample mean, where you use sigma divided by the square root of n. All right, but other than that, it's the same process because you're still looking for probability or area under the curve. All right, and again, if you need to go back and review this, right, working with the sample mean, this is what we focused on in section 5.4. All right, so if you want to go back and look at some problems specific to that, this is in section 5.4. All right, now, the one other thing that you're going to be doing here on your Chapter 5 test is taking an area that's given and using it to find the corresponding data value, all right? And this is what's covered in section 5.3, all right? So if you have not watched my videos that I posted for you on Monday for section 5.3, you need to do that first. I walk through very detailed steps for every problem in the notes, so make sure that you watch those first and attempt the homework in 5.3. All right, now, once you've done that, what's important to note here, again, once problems are all mixed up, is how do I know this is the method that I need to use? All right, and there's two big hints here. All right, one is that the information given, right, a percentile, is giving me an area under the curve. All right, specifically, anytime I'm looking at a percentile, all right, the 80th percentile would be written P with 80 as a subscript. All right, percentiles give you the area to the left as a percentage. So the to its left of 80%. And that's true for any percentile. So if you wanted to do like the 34th percentile, that means 34% is the area to its left. All right, so the first thing to note here is instead of being given a bill amount like we had in the previous problems, we are given an area, all right, specifically an area to the left, and in decimal form, 80% is an area of 0.80. All right, the second thing to note here, what lets me know that this is going to be different, is I'm not asked to find a probability. I'm not asked to find an area. I'm asked to find a bill amount. All right, this means I'm looking for a data value, which is a value of X. Okay, so it's exactly the opposite of what we've been doing. All right, so this method, right, what I do in this particular case is I take the given area and I look for it inside the table. Okay, you do not look for areas out here. Those are z-scores. So if you have an area, you look inside the table. All right, and so a lot of times what I do when I'm given an area is I go ahead and write it to 4 decimal places. That way I'm not tempted to try to look it up on the outer edges. Now sometimes you'll get lucky and find your exact area, all right, but many times you'll have to just get as close as you can to the required area. All right, and that's what's going to happen here. So when I start searching through, my areas do go in order. So 0.5, 0.6, 0.7, right? I'm just kind of following the trend. And then what I should notice is I come to 0.7995, and then it jumps to 0.8023. So if 0.80 was in this table, right, it would be in between those two. Okay, that means I can't find the exact area. So what I do in that case is I pick the area that gets closest to what I'm looking for. And in that case, 0.7995 is a little bit closer to 0.8 than 0.8023. Now, what that's going to do for me is it's going to give me the z-score that corresponds, right? Because z is what's on the outer edges of the table. So using the row, right, for that closest area, I can determine that to one decimal place, I'm looking at 0.8. And in the second decimal place, using the column, I'm looking at a 4. And this is a z-score. Notice how I'm labeling so that I understand what it is I've found, right? I haven't found the bill amount yet, right? I'm not there yet. I have found the z-score. Now, if the question had asked me to find the z-score for the 80th percentile, I would be done. That would be my answer. And some of the questions in 5.3 do that. They ask you for the z-score. If I'm asked for a data value, a bill amount, a height, a weight, a temperature, whatever it happens to be, then what I have to do from here is I have to take that z-score and transform it back to the data value. And this is the formula that you use to do that. Mean plus z times the standard deviation. So what I'm going to do from here to get the bill amount is I'm going to take that z-score that I just got from my table, 0.84. I'm going to multiply it by the standard deviation, all right? That's 12 here. And I'm going to add that to the mean, which is 100. So z-score 0.84 times the standard deviation plus the mean gives me a bill amount, so I'm back to money here, all right, in dollars, a bill amount of $110.08. And that's what I'm looking for in this case. All right, again, this is what was focused on in 5.3, all right? So if you need to go back and review this process, go back to my videos that I posted in D2L for section 5.3. There's several of them in there, so make sure to go back and look at that. All right, but in terms of our review here, what I want you to start to recognize is based on the wording of the question, right? How do I know that I need to use this method from 5.3? And it's anytime you're given an area, percentiles are always area, and you want to find a data value. All right, now with percentiles, you're always given the area to the left. All right, so you'll work it the same way. Quartiles are similar, but quartiles go in 25% increments. All right, so I did a quartile in the videos for 5.3 specifically, but with quartiles, if you want the first quartile, it's 25% area. If you want the second quartile, it's 50% area. And if you want the third quartile, it's 75% area. All right, and then you would work it the same way. Sometimes, instead of being asked to find a percentile, all right, you'll be given the area just as a percentage. And in that case, you have to be careful about whether you're given an area to the left, in which case you can go straight to your table, or to the right, where you need to subtract from 1. Okay, so something you want to keep in your mind when you're given an area, all right, if you're given a top or an upper percentage for the area, that means you're being given an area to the right. All right, if you're asked to look at the bottom or the lower end of the curve, all right, that means you're being given an area to the left. All right, and with area left, you can go right to your table. So notice in this case, I'm still asked to find a data value, which is a value of X. So I know I'm going to use the same method. And I am given an area. Percentages are always area. But it is the top 10%. So that means the area that I'm given here, right, 10% is 0.10, is an area to the right of that value. All right, now, what I have to remember is that my table only does area left. So if I'm going to use my table when I'm given an area to the right, I have to change that to an area left before I can go to my table. And we know already we can flip the direction of our area by subtracting from 1. All right, and so using your table, what you have to remember is that you have to do this in terms of an area to the left. So the area that I'm going to use here, if I write this to 4 decimal places, is 0.9000. Now again, this is an area. So I'm going to make sure I look inside the table, right? Areas are not on the outside. Change that. All right, z-scores are on the outside. So I'm looking for 0.90. All right, I scan through my areas. I come to 0.8997 and 0.9015. So if 0.90 was here, right, it'd be in between those two. So that means I'm going to take the one that gets closer to 0.90. All right, that's going to be 0.8997. That's a little bit closer. And using the row and the column, I'm going to write the corresponding z. So the row to 1 decimal place, 1.2. The column, 2nd decimal place, is an 8. And now I have found the z-score. All right, and yes, this is the z-score with 90% to its left, but that's the same thing as the z-score with 10% to its right, which is what we were asked to find. It's just if we're going to look up an area in our table, it has to be an area to the left. Now again, at this point, I have found z. So if the question asked me what's the z-score for the top 10%, my answer would be 1.28. But to get back to an actual bill amount, right, a value of x, I'm going to use my transformation formula, all right, where I take my z, 1.28, right, that's what I just found from the table. I multiply by the standard deviation, and I add the mean. So z-score was 1.28. I'm going to multiply that by 12, the standard deviation, add in the mean of 100, and that's going to tell me the bill amount is $115.36. And again, this is the bill amount with 90% to its left, but that's the same thing as the one that has 10% to its right, which is what we were actually asked to find here. All right, and again, these methods, right, are explained thoroughly in my videos for section 5.3. So if you need to go back and review those, right, there's lots more examples there. But then in terms of preparing for your test, what you really need to be mindful of is, when you look at a question, is it asking you to find probability, which is one method, or is it asking you to find a data value, right, which is a completely different method. Okay, now like I said, I'm going to show you how to look at these in StatCrunch as well, but I'm going to do that in a separate video. So look for my second video here, and we'll go back and talk about how I could get to these same values by using the normal calculator in StatCrunch.